Hello, this is KJ from A19AX, and today I'll be going over how to create a fairly simple state-based control system. So you'll see this a lot, but this year especially inside things like automating the controls for Lady Brown. So before we get started, let's go over how we kind of want our code to function. So I said before that this was going to be a state-based control system, but what does that actually mean? That means that we have a finite number of states, and for Lady Brown, it's pretty easy to envision. So let's say that we're going to have 3 states for now, for simplicity, and this would be like idle, loading, and scoring. And so on a lift, that would kind of look like here, here, and then maybe here. So that would be when you're resting, that would be when you want the ring to go in, and that's when you're scoring. And the way that we're actually going to change between the states is on the press of a button. So let's say R1, we want to be able to cycle to the next state. So what does this mean? If we're at loading and we press the button, we want to go to scoring. And if we press it from that position, we want to go back to the idle. So it'll kind of cycle around. And this basically allows you to control the lift with just one button. But obviously you could have maybe one button for going forwards and then one button for going backwards. It's up to you how to do it. So we said earlier that we would have a fixed number of states, but that means that each of these states would also correspond to a certain number of degrees that we would expect to see from the rotation sensor if we're actually at that point. So let's say at this one, it would be 0, which it should be 0 because that's where you should be resetting your rotation sensor from the brain screen. And let's say this one would be 30 degrees. Let's say this one, maybe 200 degrees. So we need somebody to store these values, and we need someone to move the lift so that if we want to go to the scoring state, we want to move the lift so the rotation sensor reads the value of 200. So let's go into the code, and I'll paste in some template, or not template, like setup code. So we have the motor for the Lady Brown and the rotation sensor, and I've kind of cleared out some of the other pros stuff just to make it a little more clear. So let's first create a variable to represent the number of states. So we agreed earlier that was going to be 3. And now let's make an array to store the value of the rotation sensor readings at the state. And we said before it's going to be 0, 30, and 200. So there it is. And again, if you want to add a second state or an additional state, we can make this 4, and we can maybe add like 50 in here. But let's not do that for now. And now we also need to keep track of the current state. And this was going to be the index in the array that we're at. So if you haven't used an array before, it would be basically this like a list of values, and we start from 0. So this is 0th, first, and second value. So if we go to states and 1, it would give us 30. If we did 2, it would give us 200. So we can use just a simple number to keep track of which state we're at. Okay, and now let's make a function that will allow us to transition from one state to the next. So we could just say current state plus equals 1. But you'll see that if we're at 0 and it goes to 1, 1 goes to 2. But if we're at 2 and it goes to 3, there's going to be an issue because the list does not have that many elements. So if it's 3, we want to wrap back around to 1, to 0. So let's write that in. So if the current state equals 3, we want to set it to be equal to 0. And yeah, and now let's write the code to actually control the lift. And the way we're actually going to move the lift to go to where we want is with a feedback control loop called the P loop. So I'm sure you guys might recognize what PID is, and this is just the P. And obviously you guys could add the I and D, but for my testing, I found that just P is good enough. So let's go back to this diagram. Basically how the P works is that it'll scale how fast to move the lift with how far away it is. And how far away it is going to be, let's say we're at this state, it would be this distance right here. If we're here and we want to go to here. So that would be the target minus the current value. But that means that we need to create a value for the target. And initially our target should be at the idle position. And every time we switch the state, we should update the target. And now you see how the target will update every time we call the next state function. So we need to define a constant for the KP. And so this value here will basically dictate how aggressive this controller will respond and move the lift. So now we want to find our error. And our error, we set the target minus the current. And for current, we will use the rotation sensor. And we will use .get position. So that's going to be the difference. And we need to spin the motor at a certain velocity, which we will define to be Kp times error. And now we need to actually spin the motor. So velocity. And obviously you don't really need these three variables here. You could just have it in one line, but I just have it here just to be a little bit more clear. So we want the code here to be constantly running in the background, no matter if we're an autonomous or in driver, because we want it to be always adjusting. So to do that, we'll use a task, lift. And basically what a task will do is it'll put whatever function that we give inside and it'll constantly run it in the background. So to do this, I'm creating something called a lambda function, and I will have it run the lift control in the loop. And you don't actually need to know what a lambda function is, but just know that we're creating a pros task that constantly calls the lift control in a loop, and it never ends. So now this is the easy part. Every time we press the button R1, we want to call the next state function. So we're going to use the get digital new press because we only want it to happen once. And we said that we want to call this function, so next state. Yeah. Alright, so now let's get the code on the robot. So if you see, when I start the code, it's going to go to the start position. If I click the button, it'll try to go up. And that's 3 states, 1, 2, 3. But if you see, it's not quite getting to the second state. And that's because over here where we set Kp, it's too small. So remember that like the smaller this is, the less reactive it's going to be, pretty much. So let's change it to something bigger. Let's say 4. And let's run it again. So now you can obviously see there's a huge difference, and maybe it's even adjusting too much, right? But now you can more clearly see the first state, second state, the third state. So let's maybe tone it down to something more reasonable. Let's try something like 1.4. And yeah, now that looks good. So 1, 2, 3. It looks pretty consistent. And in general, you want to tune your Kp to be as high as possible, where it doesn't have that kind of oscillating motion. So that'll give you the most consistent and the quickest results. So let's say we wanted to add another state. So again, here we want to change our num states to 4. And then let's say we wanted to have a state maybe at this vertical position. So let's try, I'm just going to guess something here, 300 here. If you see now, instead of 3 states, we'll have 1, 2, 3, 4. 1, 2, 3, 4. So yeah.